Additive manufacturing is actually very simple. A machine takes a digital blueprint and places the material where you want it in order to build a product.
It's a great example of a foundational technology with a strong potential to lead to major transformational impacts across a broad range of product sectors.
Rip, mod, burn is actually the concept that's very familiar in the music industry of recording a track and editing that track and then creating something new and burning it onto a CD. In the world of 3D and 3D printing, the rip is the reality capture, capturing something, an object or an environment around you, modifying that, editing the three-dimensional form, and then burning that through 3D printing.
There's a lot of applications where 3D printing makes a lot of sense. When you're creating one-off objects, when the unit costs, you're very happy to have the first unit cost the same as the 100th unit, as the 1000th unit, when customization is required. Also, when you don't want to maintain a lot of things in inventory.
And in a way, additive manufacturing can take us through the last mile of manufacturing automation, typically the assembly of our products. If you take your mobile phone, for example, and most of the parts in the mobile phone are produced with traditional manufacturing processes, at the end of the day, those things need to be put together. And right now, it's very difficult for machines, for automation, to put these pieces together. The little plastic connectors that are inside, the little screws are hard for a robot to hold onto and screw in. So additive can really bring us a long ways to automate some of those processes, and as a result bring back a lot of the jobs that have gone overseas, because we can now do that production here with our own labor.
These impacts can come due to increased competitiveness, like reducing response times from product ideation to product delivery, things like rapid tooling production, but also as direct fabrication of customized products to a very diverse customer base.
And the ways that it does that are by reducing the number of parts, first of all, is a great benefit of additive manufacturing, that you can take multiple functionalities and put them into a single part, and make that single part designed so that a robot can take it and put it together more easily.
But it's not going to replace all of manufacturing, because when you're talking about very large-scale manufacturing, or when you know that you're going to make more than a certain number of units, and you want to achieve efficiencies from the diminishing costs of tooling up and then running a production line, then traditional manufacturing techniques will still be more economical.
It's important to realize that this technology extends well beyond the type of technology that's available to the consumer and that is typically being used at more of the hobbyist and the fab lab level, where you could describe these things as essentially a hot glue gun that lays down molten polymer. And the capabilities of the equipment go far beyond that, but associated with that, there's a significant price tag. Historically, the use of this technology has really been focused more around prototyping, where design engineers can visualize what a product will look like. So that was what really was the initial rapid prototyping impetus of the technology, was being able to take something from a virtual design space or a paper drawing, because this goes back several decades. So a lot of the design work was still being done on paper at that point. And now they could take something and turn it into a tangible product that they could hold, they could show to customers and say, this is what we envision the product that we would make for you would look like. And I think in the shorter term, there's been a lot of speculation about supply chain revolution, where less exotic parts, less fancy parts that are built on demand from an electronic library rather than a physical warehouse. And so having a localized additive manufacturing capability to on-demand produce a specialized part for your 1972 Corvette that might be a little bit difficult to track down, but if you manage to have an electronic version of the file and a local additive manufacturing facility, you might be able to have that part built for you on demand.
10 years beyond, things start to look very interesting, where we have new material technologies coming out, new machines with broader capabilities coming out that will start to entirely supplant the existing supply chain. And probably the most interesting aspect there is the ability to manufacture where you need the product. So instead of having this very centralized system that we've really relied on since the first industrial revolution, this was all based upon building a factory by a river which supplied the materials and also powered the water wheel that drove all the machines inside. And we really haven't decoupled ourselves from that fixed industrial base. With additive, we now have the ability to create a factory wherever we need it.